All right, so in this video, we're going to take a look at writing a class in which we'll use the rule of three. So we discussed in our last video that we can have classes that have data members that can reference things out on the heap. So what that means is we're executing a particular program, we can actually create something out on the heap dynamically, and then we can have a data member referencing that thing. And in those cases, we have to go in and actually write a copy constructor, an overloaded assignment, and a destructor. Okay, so let's go ahead and get started. So I'm going to go here to File, and then to New, and then to C++ Project, and specify the name of the project. The name of the project I'm going to have is Rule of Three. You can name it whatever you like. And I'm going to have empty project specified here, and then our tool chain is going to be min.gw. And go ahead and click on Finish. So now we have our project here, which is just a folder on our system. And I'm going to right-click on that and go to New, and then specify that we're going to create a header file. And so the name of this header file is going to be gcharacter.h. So G is for game, so we're just imagining that we're creating a header file for a game character. And go ahead and click on Finish. So now we have our game character, our gcharacter file, our gcharacter.h, and this is where we'll specify our class interface. Okay, so the first thing we need to have is a couple of #include statements. So we'll do a #include for IOStream, and we'll also do another #include for the string class. We need to have both of those in this particular class. And then we'll go ahead and create our class, and it's going to be called gcharacter for game character. Open brace, and now we'll specify, well, the first thing we'll specify here is a friend function. So we'll say that we're going to overload the insertion operator so that whenever we output a game character object, we can actually feed that into either the console or some other file. So we'll just simply make a friend here and say std : for the scope operator, ostream, ampersand, and then operator, and then whatever operator we're overloading. In this case, we're overloading the insertion operator, and then open parentheses and specify the parameters there. So we'll have std : ostream, ampersand, os, comma, and then we'll pass in a constant reference to our gcharacter object. So we'll have const, and then gcharacter, and then ampersand, and we'll just say the name of that is gc, semicolon. So that's just simply a function prototype for being able to overload the insertion operator. I covered this in more detail in one of my previous videos, and I'll probably put a link to that video in the description to this particular video if you want to go back and review what's going on in terms of the syntax there for overloading the insertion operator. So now we'll have a public section here for our class. So in the public section, we'll have a static member for the number of elements that we'll have in our tool array. So we'll say static const int, and I'm going to just call this default capacity. So if we're constructing a new gcharacter object and they don't specify a particular capacity for the tool capacity, we'll say that it's 5. So we'll have that. And now we'll specify the constructor. So we'll have a comment here to say that we're writing the constructor. So this is going to be, the constructor always has the same name as the class. So we'll have gcharacter here, and then have open parentheses, std : and now we'll have to specify a string for the name. So in this particular example, I'm going to depart from what I covered in the theory or conceptual video relating to these concepts of using the rule of three. And I'm going to just specify that we have a name for our gcharacter and that we have our capacity for the number of tools that we can have in our tool array. So what I'll say here, we'll make this constructor also act as a default constructor. So if they don't specify a name for the character, we'll just say that the name for the game character is going to be John. And then we'll say int capacity, and we'll assign for the default value there. If they don't specify a default value whenever they construct it, we'll say that it's going to be the default capacity. That was the whole reason we did the previous line, right? So now we have the default capacity, and in that with a semicolon. So now we have our prototype, our function prototype for our constructor that also acts as a default constructor. So now we'll have a copy constructor. So that's one of the new things that we're looking at. So it turns out that the function prototype for the copy constructor starts out very similarly to our constructor. Since it is a constructor, we'd start with G character here. And we'll have open parentheses, and then we'll have const space G character. So what we're going to do is we're going to pass in a G character by constant reference, if I can spell correct character here. So we have G character, ampersand, and then source, and then semicolon. So that's the only thing we need there for the copy constructor. So we'll be constructing a brand new G character object based off of some particular G character object that we're passing in by constant reference. So that's what's going on here in the parentheses, is we're just specifying the G character object that we're going to be referencing to construct a new G character object. And then we'll have our overloaded assignment operator. So we'll do overloaded assignment. And for overloaded assignment, we're going to be returning a reference to a G character object. So we'll have G character ampersand here. And the reason why we want to return a reference to the G character object that we're doing the assignment to is so we can actually chain multiple G character objects together with the assignment operator. So you could have GC1 assignment operator, GC2 assignment operator, GC3 semicolon, or whatever it may be. So if we didn't have that, we wouldn't be able to do those multiple chainings between assignment operators. So now we'll have operator, and whatever operator we're overloading. I'm trying to overload the plus operator, but we need to do the assignment operator. And then we'll say const, and then G character. Should have picked a much shorter name for the name of our class here. So we got G character, ampersand, and then source is just the identifier I'm going to use. And that's the end of the overloaded assignment operator prototype. Again, we're passing in by constant reference some particular G character object that we need to base or do the assignment from. So we're assigning from this particular G character object here. And then finally, as part of our big three, we need to do the destructor. So I'll specify destructor here as the comment. And the destructor is really simple in terms of the syntax for the prototype. We just use the tilde, and then we say G character, and open paren, close paren, semicolon. And that's it. That's the only thing we need to do for the destructor. And then I'm going to have one member function in here other than the big three, or the rule of three. So we'll do insert. I'll make a comment here that we're writing an insert function so that we can actually insert a new tool into the tool array or the tool holder. So we'll say that this is a void returning function. The name of it is going to be insert, and we just pass in by constant reference whatever the name of the tool is that we're going to be adding in. So if you watched the video in which I was covering the theory and the concepts related to this, you would have noticed that I made use of a tool class or tool pointer whenever we're referring to the tool array. So instead of actually having a tool class so that we can have a tool pointer, I'm going to just have a string class. And so we can make use of a string to actually specify the name of our tools. So that's going to be passed in by constant reference since we're not going to be changing the name. So we have that is the function prototype for the insert. And now we can go in and write our data members in our private section. So we'll have a private section here, and then we'll just specify a comment saying data members. So we have only 4 data members in this particular example. So the very first data member that we'll have is for the name of our game character. It's of type string, and then we'll have an int for capacity. So that's specifying the capacity of our tool array. And then we'll specify the number of elements that we've actually used in that tool array. And then finally, we'll have another string. And this time we'll have a string pointer that's able to reference our particular tool array, which is going to be of type string. And we'll just call that one tool holder. And that's it. That's all we need to have in terms of the header file. And now we can go to the CPP file and actually specify the definitions for this particular class. So let's go and do that. All right, so we go back up here to our project, and we're going to create a new source file. The name of this source file is going to just be gcharacter. So we'll have gcharacter.cpp, and click on Finish. And so this is where we'll do our actual implementation. So what we'll need to do is do a pound include and include our G character and .h file. And the next thing that we'll do is just do our using namespace standard semicolon. And now we're ready to start writing our actual definitions. So the first definition we'll write is just for the constructor. So maybe I'll put a comment here that this is our constructor. So we'll specify the name of the class, which is G character, and then colon, scope operator, and then we can specify our constructor, which just simply takes a string for the name and an int for the capacity, and I'll just use in and cap. We could use an initializer list here, but I'm going to just put everything inside of the body. So we'll have an assignment here for in to name. We'll assign cap to capacity. So we're just initializing our instance variables here with those things that have been passed in. Used will be initialized to 0. And then we'll also need to create a new string array for our tool holder. So we'll have tool holder, which is a string pointer, and assign that to a new string array. And the size of that will be based off of the capacity. So that's pretty much it for the constructor, not too bad. And now we'll create the copy constructor. So here we go with the copy constructor. And the copy constructor, somewhat similar. We still have, we have G character here, colon. This time we'll specify the copy constructor. So this time we're passing in a const. It's a constant reference to a G character object. And we'll name it source, just like we did in the prototype. The first thing that we'll do inside of the copy constructor is simply do a cout operation to indicate that, hey, we've actually are invoking the copy constructor, so we can see what happens or when this is actually being invoked. So we can just say copy constructor called, and we'll just do an indel here. And now we actually get into the business of copying or assigning the stuff from this existing G character object that we passed in by constant reference, and we're wanting to assign it to the G character object that we're now creating. So the G character object that we're now creating is the actual object that invoked the copy constructor. So whenever we specify name assignment source.name, what this is saying is take the name associated with this particular G character object here and assign it to the one that we're now creating, or the one that we're now initializing. So we'll do the same thing for capacity. And we'll also do the same thing here for used. So that will come over as well. And then we'll take tool holder. Now, with tool holder, we don't want to reference the same exact string array for the source G character object. What we want to do now is actually create a new string array so that each G character object can be referencing its own string array. We want to do a deep copy as opposed to a shallow copy. So in order to do a deep copy, we need to actually create a brand new string array. But the capacity will be based off of the capacity from the source. All right. And so the next thing that we'll do is we'll make use of a function from the standard template library. It's a copy function, and it takes 3 parameters. The very first parameter specifies a pointer, basically, that will point to the location of where we want to start the copy from. The second parameter specifies the point where we want to copy up to, and then the third parameter specifies where we want to copy it to. So we'll specify tool holder, and that there is just simply a pointer. So the name of our array tool holder will get us to the very first element of the tool holder array, and then we can say source dot tool holder, and then do some pointer arithmetic where we add on used. So that specifies how many elements we need to shift down, and then we want to copy that to tool holder. And this tool holder here is associated with the object that's just now been constructed. Okay, there's another way that we could do that. If you feel more comfortable, you could have made use of a for loop. So we could have said for int I assignment statement 0 as long as I is less than used I++, and inside the for loop, the only thing that we would need to do is just copy over each element into the new array associated with the new object. So we'll do tool holder here and specify I. So that's hopefully not too bad. So that's our copy constructor. Again, you could make use of the keyword this, but it's implied. So you could have, this dot name, this dot capacity. So all that could exist there. Notice how Eclipse is really nice in the sense whenever we say this dot, it recognizes that this is a pointer and it needs to do a dereferencing. So it changes it to the correct operator there to actually dereference that pointer to the particular object that we're referring to. And so you could say the same thing over here. You could say this dot tool holder. Okay, so we always have to have some particular G character object performing any of these operations that we have associated with this class, and this just simply refers to that particular object. All right, so the next thing we'll do is the overloaded assignment. So we do overloaded assignment operator. So this is a case where we're going to return a G character object, and it's going to be returned by reference. And we'll specify the name of the class, scope operator, and we want to specify that we're overloading the assignment operator, and we pass in by constant reference a reference to a G character object. So that's being passed in by reference. We'll call that one source as well. So inside of the body for the overloaded assignment operator, we'll do a print statement once again. So we'll do a cout, and we'll just simply say overloaded assignment called, just to indicate whenever we call this, and do an endl. Because I think people, whenever they're first introduced to these concepts of the rule of three, they sometimes get confused in terms of when the copy constructor is invoked and when the overloaded assignment is invoked. Turns out that for the overloaded assignment operator to be invoked, we already have to have a particular G character object or whatever the object is already in existence before we do the assignment. In the case of the copy constructor being invoked, it's a case where we didn't already have a particular object, in this case a G character object already in existence being invoked. All right, so the first thing that we'll do inside of the overloaded assignment operator is check for self-assignment. So let me go ahead and just write the comment here. Check for self-assignment. So this is a case where we may have, say we have GC1. So we have some particular game character called GC1. And what if we did self-assignment where we said GC1 is assigned to GC1? That's should be allowed syntactically, but we don't want to do any more work than we have to do. Since we're referring to the same exact object, then what we can do is just write an if statement here and test to see if this is equal to ampersand source. So we're simply seeing if the thing that's on the right-hand side of the assignment statement is equal to what's on the left-hand side of the assignment statement. So that's what's going on there. And then if that's the case, we'll just simply return the G character object. And notice that we do have to do a dereference there because this is a pointer and we're actually wanting to return the G character object itself. Well, it's going to be returned by reference because we've got the ampersand specified here, but we have to actually return, at this point, specify that it is a G character object. We're not trying to return the pointer itself. Okay, so for the next piece, it's going to be very similar to what we did in the copy constructor. So I'm going to go ahead and copy these lines of code here, 26 through 31 in my case, and paste them down to below. We can get rid of one of the lines of code. Turns out that we do not need to have the line of code where we're actually creating a new string array because we would already have a string array associated with our gCharacter object. We're not creating a gCharacter object for the very first time. We're just trying to copy the contents of one gCharacter object into another gCharacter object. So I'm going to get rid of that line of code, but the rest of it pretty much comes down as is from what we had above. Let me make sure, I forgot to do this. I'll comment out these lines of code here for our for loop, since that's serving the same exact purpose. I forgot to do that previously, but those lines of code should be commented out. So back here in the overloaded assignment operator, we're almost finished. The only thing that we have left to do is to do a return statement where we actually return our gCharacter object in this particular case. And that is basically all that we need to do in the overloaded assignment. So fundamentally, we're just taking one particular gCharacter object and copying it over to another gCharacter object and testing for self-assignment. So it's very similar to what we had in the copy constructor. All right, so now we're ready to write the destructor. So let's go ahead and write the destructor. And so the destructor here is the one that had the tilde. So it doesn't take any arguments. And in terms of the body for this particular function, it's pretty simple. I think we'll do a cout operation just to say that we're invoking the destructor. So we'll just say destructor. Actually, let's be a little bit more sophisticated in terms of what we do with the destructor. We'll say destructor called for, and then we'll specify the name associated with the particular object. And then we'll say, continuing on that particular string, we'll say that it's at this memory location. And the way we can go about getting the memory location is just by printing out the pointer this. So this is just holding some address value indicating where that particular gCharacter object is in memory. The last thing that we need to do is a delete operation. Let me make sure I change this. For whatever reason, that's not changing. So that should be like so. And then we'll do a delete operation. This time we're deleting an array, and we're deleting the tool holder, or what tool holder points to, which is a string array. So that's the only thing we have to worry about. So the destructor is only handling the dynamic memory that we allocated. Any other memory that was allocated, we don't have to worry about. It's just the dynamic memory that we have to be concerned with. All right, so we've got the destructor. The next thing we'll code up is our insert. So I'll have a little comment here saying that this is for inserting a new tool into our tool holder, being verbose there. So this is a void returning function. Let me scroll down a bit. So we got void gCharacter, and this is our insert. So this is a constant reference to our string, and we'll use the word tool name for the identifier. And in here, we'll just say if the use capacity, or excuse me, if used is equal to capacity, we know that we cannot put any more tools in there. So in this case, we'll just do a cout operation and just indicate to the user tool holder is full, cannot add any additional tools. Okay. Maybe we'll come back later and change this up a bit so that we can have a dynamic array that can expand if we need to add in additional tools. So if that's not the case, we'll have just an else statement here. And in the else statement, this is where we'll actually add in the tool. So we'll just say tool holder, specify the index by using the used variable, and then using whatever the tool name is. And the other thing we have to make sure of is to increment used. Otherwise, used won't actually hold the proper index value. Got to make sure that that's being incremented every single time we do an insert operation. All right, so let's do one more. We still need to do our overloaded insertion operator. So we'll do that. So this is our overloaded insertion. Very similar stuff to what we've seen before. So we pass in our OStream object by reference, since we will not be modifying the OStream object itself. And we'll also pass in our GCharacter object by reference, our constant reference to be more specific. We'll just call it GC. And in here, we'll do a string that just says game character, whatever game character we have. So we can get the name of our game character, gc.name. And I'm going to come to the next line. And let's see, we'll do a new line character and say has the following tools. And here we'll just say std : indel, and then we'll also concatenate on a pipe symbol, or we'll output a pipe. And what we'll do is actually iterate over our tool array and just simply print out the tools that we have. So let's see. So we've got that, and now we'll have our for loop here. So we'll say for int I 0, as long as I is less than gc.use. And then in here, we'll output some more stuff. So we'll say gc.toolholder and specify our index using I. And then we'll concatenate on a pipe symbol, just so that we have a pipe separating each one of our tools. And we'll do a semicolon. And then outside the for loop, we'll just simply return our OStream object there, specified by OS. And we'll also do, an indel, just so we have a new line character there. And that is pretty much it for our gcharacter.cpp file. So we've done the implementation for everything that we set out to do. So we have our copy constructor, we have our overloaded assignment operator, we have our destructor, we have that other member function that we wrote for doing an insert of a tool into our tool array. And now we also have an overloaded insertion operator. So that means that anytime we do a cout insertion operator and reference or have on the right-hand side a GCharacter object, we'll be able to make use of this. It'll automatically be invoked. All right, so now we'll go in and create another source file, and this will be just our application file. So we'll call this one gcapp.cpp and click on Finish. And we'll get started writing our GC app. So in this particular file, we'll do a pound include. And we really only need to do one pound include here. We'll just do gcharacter.h, and that should be sufficient. And then we'll do our using namespace standard. And now we'll go about creating a main. So this is our application that's going to be making use of that gcharacter class. So the first thing that we'll do is maybe invoke the default constructor and see what happens there. So we'll do gcharacter, and we'll say gc1 is the name of this particular gcharacter object. And then we can go and insert stuff into that gcharacter object. So we'll do gc1.insert, and we can specify whatever tools we want to have. Maybe we have a potion in our tool array, and I'm going to just copy this line of code and paste it, and paste it a few more times. And come back and make some changes just to the string. So we don't want to have 5 potions. We'll just have a crossbow. We'll have say a candle. We'll have maybe a cloak. And the 5th thing that we'll have is a sword. Let's add one more. And we shouldn't be able to fit another one in there. So we'll just specify maybe Book of Spells, but this will not actually get added in because we only have 5 elements in our tool array by default. So let's go ahead and just test this out and see what happens. So let's do cout gc1 insertion operator indel, and let's see if things actually compile. So go ahead and build this. Looks like everything compiled okay, and let's see what happens when we run it. So whenever we run this, you can see that the very first statement that we have here, tool holder is full, cannot add any additional tools, that occurred from this line of code here because we were trying to add in another tool to our tool array and when we weren't able to fit it in. So the next couple of lines was just related to whenever we did the cout operation. So we did cout gc1 indel, and that produced all of this business here. So we got game character John. So John was the default name since we didn't provide a default name here whenever we created our G character object. Has the following tools. So it has, potion, crossbow, candle, cloak, and sword, just like what we specified here. And then you see another line of code down here. You see where our destructor was called. So destructor called for John at this memory location. So that's the location of that particular G character object. And the reason why that got invoked is because as soon as we terminate main, then all the things that got allocated on the stack, which this thing here was allocated on the stack since we didn't use the keyword new, then it gets removed. And so the destructor is being called there implicitly whenever we terminate the main function. All right, so let's do something else. Let's create another G character. So we'll create this G character, GC2, and we'll specify that the GC2 is going to be using Bob, and we'll still use 5, I guess, for the size. The reason why I want to keep the sizes the same for our tool array, if you go back and look at the way that we coded up our overloaded assignment operator and also our copy constructor, they're only able to really have situations in which the source would have to have at least the same or less than the number of tools that the destination G character object would have. Certainly we could change this up. We may come back and write in some code where we can have G character objects that do in fact have different size tool arrays. Okay, so we've got this being created, GC2, and we can do GC2.insert, and we'll insert an axe in this particular case. So GC2 Bob has an axe. And let's see, I think the next thing I want to do is actually create an example where we pass to a function a G character object and also return a G character object. So it turns out whenever we pass a G character object to a function, we'll get an invocation of the copy constructor, and also whenever we return from a G character object, whenever we return from a function, if we return a G character object, then we'll get an invocation of the copy constructor. So I'm going to come up here before main and do G character G character, and do the name of this function. I'm going to just call it example copy constructor. I don't know, it's kind of a dumb name, but I just want to show you what happens whenever we pass a G character object in by value. So I'm going to have the identifier there for a G character object called temp GC. And then in here, I'll just do a couple of cout operations just so whenever we run this, we can see what's happened. So we'll say that the copy constructor is used twice, or maybe I'll say called twice. So it's getting called one time whenever we actually pass this thing in by value. And I'll do another cout here and actually specify that. So once for the formal parameter being passed by value. Okay, so we have that. And then we'll do another cout, and this will indicate the the other time that the copy constructor is being called. So it's being called once for the return value. So it's returning the gCharacter object by value. Now notice in this particular function, we're not actually manipulating anything related to the gCharacter object. We're basically just showing what happens whenever we pass and return gCharacter objects, that the copy constructor is actually being invoked. So we'll just return temp GC. Okay. Turns out that we'll also get an invocation of the destructor as well. All right, so we have that, and let's go and actually call that. So we'll do call to example copy constructor function. And we'll just pass in GC2 and do a semicolon there. And let's go ahead and run that and see what happens. And we'll save that and build it and run this. All right. We got a lot of stuff going on here. So we've got the same code that we saw before from our first few statements. And now you see that whenever we got to this particular line of code here, so whenever we did gc2.insert ax, we were okay with doing an insertion there, so we didn't have any problems since we have 5 elements. So that didn't output anything, but whenever we called the example copy constructor here, you can see that it said copy constructor called. So this line here, copy constructor called, was being invoked from our actual copy constructor. So if you remember, whenever we wrote our copy constructor, we had the C out here where it says copy constructor called. And now it's just outputting the stuff that we have inside of that function. So the stuff that we just wrote. And then the copy constructor gets invoked again whenever we do the return of the gCharacter object. And then you notice that we have several destructors being called. So you see the destructor is being called twice here whenever we had GC2. And so what's happening here is in this example copy constructor, we had 2 gCharacter objects being placed on the stack, the one that's being passed in and the one that's being returned. And so both of those get destroyed whenever we terminate this particular function here, xcopy or example copy constructor. So those are those 2 lines of code there, or excuse me, those 2 lines being printed out. And the next 2 lines here relate to GC1 and GC2 being popped off of the stack whenever we terminate main. So whenever we terminate main, the destructor is being called twice, and you can see that those do in fact have different address locations out in memory. All right, so let's do a couple more things. This is turning into a really long video. So this time we'll actually go in and make use of the copy constructor again. So let's do gCharacter, and we'll do GC3, assignment operator GC2. So this is a case where GC3 wasn't already in existence. Since it wasn't already in existence, we won't be invoking the overloaded assignment operator. We'll be invoking the copy constructor. So it's a very different story that we have here. If we wanted to see the overloaded assignment, so let me put a comment here and say that this is the copy constructor being invoked in this particular case. And we'll do an example where we do the overloaded assignment operator. So the way that we would do that is just maybe we'll take GC2 and use the assignment operator and use GC1. So both GC1 and GC2 were gCharacter objects that were already in existence, and so we'll get an invocation of the overloaded assignment operator. So if we want to, we'll save that and build it, and we'll run it, see what happens. So again, if we scroll back up here, you can still see all the code that we had before. The new stuff that's going on here is we see that the copy constructor is being called whenever we did this line of code here. The overloaded assignment operator is being called whenever we did this particular line, and then you can see the destructor being called for each one of those. Now you notice that we do have a couple of things that have the same name in terms of the attributes, which is perfectly okay, but they are three distinct objects out there in memory. So you can tell that they're three distinct objects, GC1, or GC1, GC2, and GC3 by these values here. Okay. And I would assume that since these are placed on the stack, that they're being destructed or popped off of the stack, or whenever they're popped off the stack, the destructor is being called in the exact opposite order that we created them in. So it would be last in, first out. So the very last thing that we created was GC3. So this is no doubt GC3 here. This would be GC2, and this would be GC1 that's being destructed there. All right, so we have that. Let's see what else we can do. Okay, so the last thing that we'll do is just a couple of cout statements. So let's just do a cout, and we'll do GC2 colon, and we'll actually invoke the overloaded insertion operator. And we'll do the same line of code basically. So I'm going to just copy that, paste it, and change this up to being GC1, just so we can see what happens here. And so I'm going to save that, and build it, and run it one more time. And we can see what happens. So we can see in this particular case here, whenever we did the cout operation, we got GC2, which is John and John. And you can see that they have the exact same values there for their tool array. If we wanted to, I guess we could also do Bob. So that was GC3. So we'll do one more here, where we do GC3, and save that, build it, and run it one more time. Okay, so now we can see Bob being printed out. And yeah, so this is GC3. So you can see that GC3 is in fact being popped off the stack first because that's Bob. GC3 is the only one that has the name Bob, whereas GC1 and GC2 have the name John, since they made use of the default constructor. All right, so that is pretty much it in terms of this particular video. I'll probably put the actual code maybe with some additional notes up somewhere and put that in the description in terms of where you can find the code and download it and look at the more detailed comments that I have. All right, so that's it. So hopefully you know a bit more about the rule of three and when you have to use the rule of three, the syntax for writing a copy constructor, overloaded assignment, and a destructor. Again, with the copy constructor, that's going to be invoked any time in which we may do something like this, where we're assigning one particular object to another object, and we have a class in which the copy constructor is written, and this particular object doesn't already exist, so we would have the copy constructor being invoked. The other two times that we would have the copy constructor being invoked is whenever we're passing a particular object by value or returning an object by value from a particular function. In terms of the overloaded assignment operator, we would have that being invoked if we had some particular objects already in existence, such as GC2 and GC1 in this case, and we're just wanting to take all the things here that we have in GC1 and assign it to GC2, but we've done a deep copy here as opposed to a shallow copy. Same thing here, a copy constructor also does a deep copy. The destructor, once again, is just taking care of those things that we allocated out there on the heap dynamically using the keyword new, such as our tool array. All right, so that's it, and hopefully you enjoyed this video.